here. So I did some work. I did a pretty good amount of work. I can show it here in just a minute. That. All right. Let's start. There we go. There we go. Okay. Um, so I've been translating this to C++, and I think when I left off, I had built one. When I left off streaming, that is, I had built one out of it, but it was all in one function, this custom noise generator. Um, so I built custom noise generator 2, and what I did this time is I built a bunch of subfunctions to contain the various pieces that go into making the height map. Um, the only one I haven't built yet is the value noise, but it looks pretty good just the way it is. So that's something that I can always do at any point in time. And then I built also this initialize from seed method out. This is the proceduralization harness for the planet right now, which is a lot simpler than the other one because I don't need to control everything with this. I can just, yeah, let's make that even. I can just have it operate off of this smaller set of parameters, and that is a lot easier for me. So the end result of that, I'm going to do some formatting here. So what's this do? This basically defines a set of min and max value ranges that we can randomize between that should look fine and not out of place. And this is then used to initialize the way our noise is going to look. Oops. So basically my approach to building these little procedural objects is to uh, start by just building a thing that looks good with preset um, coefficients. Step one. Right? And then the next part, after you do this, take that thing, figure out which coefficients have desirable traits, isolate, group them to parameter. Take all of them that matter and expose as parameters. Use functions to group subtypes of things. All right. Then step 3, you build a proceduralization harness. Build a struct that contains randomization ranges for all these parameters. Min max can be min max vectors can be sets of things to select from, can incorporate select and bias here as well. Okay. So for example, if you wanted to have a bunch of textures that you can pick from, you could make a array of say 30 material instances or something like that, and only pick the ones that, or not even 30 material instance classes, right? As long as they share a similar parameters in there that can be edited, it's all good. Or texture objects, 30 different copies of textures. You can put those in an array, and then you can select from those. But you can also, if you want, define a wrapping structure there that contains like a selection bias that will make certain things pop up more than other things. And finally, for implement a factory method, the procedural objects, which can take in parameters or seed, which can take in seed, minimize the actual parameters to or select from is harness. Alright, that's 4. And then finally, fine tune ranges. Fine ranges that always are almost always in same output. All right. So this is the process that I've been following. Now that I've done it a few times, I'm realizing that there's a few steps that like I'm basically always following when I'm building these procedural things. So you just have to build a thing. You build it until you get something that looks good. Um, Once you got something that looks good, you take that thing, you figure out what values you're setting to in this like code or the blueprint that builds that thing. What values are you setting? And then you expose those as parameters, and you do things like grouping things into sub functions. So like for example, I was just talking about this. I have continent fault noise, continent variance noise, and continent noise, which takes in the continent fault and variance noise. So like this is combining these two things. Then I have mountain ridge noise, mountain peak noise, and mountain noise, which again, this is combining the ridge noise and the peak noise. So like these build different pieces of the equation, and I can control them independently and isolate the things that actually are effective at controlling them. So obviously I still have to implement valley noise here. So yeah, so like you end up with this, you can build, and then finally you have this initialize from seed method. This is my factory method. It's a static method. It takes in a just integer seed value, and it spits out one of these noise generators that will always generate the same patterns of noise for the same input values at that point. So that's what this is, right? And then back over here, then we need a proceduralization harness. And by that, I usually am just talking about a struct, which you can see here. We created a custom noise generator 2 bounds. We have a double bounds, an int bounds, and effector 4 bounds because those are the values that we're using to change the noise formula. So because we want to change the noise formula in ways that make sense, we want to be able to like isolate any of these values and set custom ranges on it, which is what you can see I've done here. Like these things are 1 and 1. That means they'll always be 1. I must have wanted that to be 1 because it's a multiplier and I want to have control over the contribution here. But you could do things like change these if you wanted to. Like take this higher. All right, so what this does is just basically we're defining different bounds objects to define each value that goes into these functions to build the noise that we want. And then finally, our factory method, I'm going to remove this other noise generator at some point. Get rid of this. So this is the bounds that we had from the first one I built, and you can see it's like way more complicated. Well, that's a part of narrowing this down. Like as I built these methods out, I realized like what do I need and what do I not need, and it turned out like now we're just down to this, right? Which is a lot better. So let's just go ahead and downsize. I need to delete. I need to just rename this to like Planet Noise Generator now that I've kind of landed on a formula. But whenever I delete stuff in C++, it usually is like an hour of hunting down and fixing things, so I don't want to do that. Default noise generator, yeah, sure. Oh, I'm in the header file. Derp. Blended noise. Okay, here we go. And then here's our initialize from seed method. Takes in a seed, makes a random stream from said seed, and then we're randomly picking a different type of content noise to use, spawning in our default bounds objects. And then you can see each of these, we're just basically initializing a bunch of values that we're going to use when we're building our procedural noise from our random stream and our bounds objects. You can see we're hitting min max on the vectors. We're hitting 4 of them, right? And then let's see what else. Come down here. We put everything together. And finally, we return our noise node. So this is how we actually get the noise node that we're passing off to all of our shit to make it randomized. Now we can take a look at how that all works in practice, because now we have something pretty cool. So I had the material planets that were working a while ago. Well, now we have this to around the same maturity of that. I still have to do water. I have atmosphere. I don't have the atmosphere turned on. But now we're actually making some proper planets. And we can take a look at this. And then we could say, remember that we have like a little thing here. We have thing here. Stop this. Change the seed. And we have a different planet. So oceans will be coming. It's just I don't have. I wish I had more time to mess around with this, but I simply do not. Atmosphere's done, so after I get oceans in place, The atmosphere's done. I need to work out collision and how to do that with the real time mesh plugin. I was kind of hoping that there would be some updates for that plugin at some point, which there might have been, because I haven't been keeping super close up with it. That would make it easier to do that, because I know that they had some problems with the collision generation. But once we get collision generation, we'll be able to land on the planet and walk around, um, which should be fun as well. But yeah, we can kind of fly down here. We could go over here. We get more detail the closer we get down to it. And we can also just bail out. So what's cool about this is I had one recipe for the noise, the planet noise that's making this whole effect work. But now we can change this to whatever we want. Blah 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 blah. And start it up. And we get a different planet, which is awesome. Actually super cool. This weekend I think I'm gonna hook up the material to change with it, or maybe even before this weekend, we'll see. But if the material changed as well, then you would also be randomly picking between like the problem with doing the material right now is that it needs work. Like I just have a height map texture on here right now. It doesn't do anything else. Um, and because of that, it's like it's not very sophisticated what I can do with it because like this is literally the material right now. Whereas the other material for the procedural one is like super complex. I won't like to do, good grass textures and like rocks and things like that poking through at like on like cliff sides, like normal base stuff. There's a bunch of stuff I want to do with just the material, which is probably going to be weeks of work in and of itself, most likely. But right now, this is like good enough to get me most of the way there. So I want to do multiple biomes and things like that, temperature and like moisture maps, lots of things to do in the material. And also I want to do like a proc gen material based proc gen deal too. Um, so there's a lot to go, but we are getting some pretty cool stuff in place. So let's see. This is not enough. What? We can fix this right now. That's better. Why did it do that? Almost. There it is. All right. So there, we made our material better. No, it needs is a little water sphere around it and an actual, like, this would not, in practice, this map is wrong. The reason why this map is colored like this is because um, it's a height map thing that was used on a material version, so it would have been flat. So it's used to make like combined stuff, but it's good for visualization. Once we add water logic to where there's an actual ocean in addition to the land, then all of this will become like sandy colored or like ocean floor colored, and then the water layer will give us our blues and whatnot. Oops. So now let's see. So this will be like a trip to the ocean floor here on a fault line. And if we wanted to get back, honestly, the fastest way for us to probably do that. There's other things that I gotta do too. There's an issue right now where it's probably an easy fix, but the LOD distance calculation is based off of the sphere and not the like transformed terrain, which means that the higher you are, the like it's enough to where when you're really down close to the planet, the higher the elevation of the terrain, the less detail you're going to be able to get. And it should be the opposite. Like you should be at max detail when you like enter the top of mountain level, and then getting closer shouldn't probably matter. I mean, I guess it could, but probably not. We also have the atmosphere off. All we have is this backdrop here. But hang on, we can turn that on too. I just have it flagged as not visible. Oops, god damn it. So we go here. Oh, I'm going too fast. Going too fast. Yeah, so this is a bug. Stop. Sure. Wait, stop. Oh, I think I'm seeing. Okay, that's fine. We can restart. Yeah, yeah, yeah. Actually, we can just. Yeah. Ah, ah, take that. Turn this back on permanently. At least we can see where we're at. Oh, this is the wrong. God damn it. Wrong stage. All right, so what I was gonna do, I think I'm gonna start looking at trying to come up with a good river noise here. Because that's the last thing I'm missing. So to do that, let's start with maybe this guy. And let's do Fractal Ridge. All right. Okay, let's try that. And then let's remap it so that we can pow it. No, no, no. Create a max node. So this is kind of, if we inverted this, right? We have something that kind of looks like a river cutout. So let's actually do that. Yes, that's not going to work. Not exactly. Maybe this can control thickness. And then we want to min this. One. Scale it to be a lot bigger. Let's do a smooth min. All right, and then we can min smooth, max smooth. into here. Seems reasonable. Hmm. It's not too bad. Think right here is where we could run a power. It's a pretty cool cloud texture just on its own, right? Looks pretty good. Alright, there we go. Now, what if It might work. So if I pop in here, then valley noise. Um, we know we want the mountain noise. We might want the ridge noise. Continent. Fault. Okay. All right, and with those, let's see. I actually need to shift around here. Hang on. Yeah, I know, jeans, but I gotta move because my back's hurting. All right, there we go. Okay, so let's look back at what we did over here. We're just gonna try to reproduce this and see what happens. We used Open Simplex. We did a 16 octave fractal ridge. Source noise. Oops. Okay, and then 16 octaves, 5 to in a remap to 1.3. All right. Oops. Sorry. Let's see. Remap. And I do want to try the weighted strength at 0.5. Okay, good enough. Sure. We need a power. Set it to the ridge noise. Set it to, I think, 8 for now. I actually think I do it after this. Take it back. Okay. Uh, um, domain warp. We can do the smooth minimax here. Okay, we do that. Smooth M, smooth max. Domain warp's the last thing we want to do, I think. Oops. Go sub set LHS. So he flipped it. Gonna need a multiply. subtract it, I actually need to do a second subtraction. We don't want it overlapping the mountains, so we'll do sub 1 set left hand side smooth max sub 1 set right hand side to in mountain noise should come before the minimaxes actually. Yep, this should come here. There we go. And then sub 2. There we go. And then, so then we have a flipped, basically erosion map. It hasn't been distorted yet. Distortion has to come before this. Hmm. Amplitude. Okay. Okay. There we go. Okay. First we distort it, the base. Then we subtract our mountain noise from it. Then we do the rest of our shit to it. Finally, we're flipping it, so we're subtracting it from 1. Then remap it, I guess. All right. Let's try it just like that. Planet noise C++. Now up here where we're building our shit, in mountain, in fault. Okay, so we want the mountain noise and the. All right. Then we come back out to where we just were, right here. Okay. So yeah, this impacts it. It might be a little much. Yeah, they're just too wide. Let's also. This is now you see why I turned the atmosphere off. Viz. All right, so like the scale is way too big, right? So that's an easy fix. Oh yeah, I didn't scale it at all. About 14. Okay, so obviously that's not going to work. However, let's not rush to judgment here. Excuse me. Yeah, it's not exactly right now, is it? Instead of doing it this way, let's do it like this. So instead of subtracting out here, we'll subtract it over there, basically, outside of the function. Well, that's not gonna work. Hang on, we have to change it. Let's see what happens. Yeah, shouldn't that one work? Let's see. So it totally makes sense that it would result like that because right here Yeah, it's just a little too much. Hang on. It'll probably take me playing with this for quite a while to make it work properly the way that I would like it to look, but it's not, I mean, it's obviously it's too much coverage. I have to figure that out. These like tributary areas don't look too bad. All right, now I want to try maybe a couple different seeds. So obviously this function still needs work for the rivers. I'm gonna have to come up with something better. This is probably not good enough in its current state, so I have to iterate on it. Yeah, that's no good. And I may look into actually doing, since I have all the height map information on each square, I may look into some actual like erosion calculations to do that. We'll see. Probably gonna hop off and play some Magic though. That's what I'm thinking right now. Um, so yeah, this is like it's coming along. We have a proceduralization harness right now, which is big. That's the big thing that I did over the weekend, and we can generate random planets for every seed number, which is what, 4 billion something variations. I would like to put like a regenerate button in here soon that would let me change the seed while the game is running and then regenerate it. Think that would be handy for testing purposes. Ooh, he's interesting. And obviously, there's tons of work to do on the materials as well. Um, like I showed them earlier on, they're just very basic right now. All right. Later. I'm gonna be on again playing Magic here in just a second, so stick around if you want to see that. See ya.